Hello everyone, now let's look at section 4.1 part 4, empirical probability. And the only difference between empirical probability and the classical probability is the classical probability is using the count from event and sample space. So if we look at the empirical probabilities equation, which is the number of outcomes in the event and number of outcomes in the sample space. But for empirical probability, we're looking at the frequencies. So the frequencies for the class divided by the total frequency in the distribution. So we can say empirical probability is based on observation. And it's still using the similar formula, probability of this event E equals F over N. So we also call this an F over N rule, empirical probability frequencies. So now let's look at a interpretation of probability by the example, toss a fair coin. Also, this is known as the law of large numbers. The law of large numbers. So two computer simulations. So we can actually do a experiment, just toss a fair coin. So look at the proportion of hats we got from all the tosses. So we could have the first toss, and then we observe a hat, and then a hat again, and then a tail, and then tail, a hat again, a tail, a hat, tail. Could be a lot of tail, and then a hat, and tail. So we can then calculate the proportion of hats. So for the first one, we toss just one time, and then we got one hat. So it's 1 out of 1. And then for the second one, so now we toss two coins, or toss the coin twice already. And then we look at it, we got two hats, and then we want to look at the proportion of hats because we have two tosses, so 2 out of 2. And then for the third one, we can also count. We have 2 hats, and then out of 3 toes, and then 2 out of 3. So if you look at those, it changes. So it could be 1, and then sometime it dropped to 60%. This is 66%, and then go to 50, and then it could go up and then go down. So this number is keep changing until you do this for 100 times, and you'll see then the proportion, this calculation, as this denominator go up, so this, no matter how it looks like, this gonna be approaching the 50%. Because why it will approaching the 50%? Because we call it a fair coin. So that's why. So an issue has equal chance to land on head or tail, and the proportion of heads will approach 50%. And this is a law of large numbers. And if you do this more for more tosses, 1,000 times or 10,000 times, this line gonna be exactly overlap the 50% straight line there. Okay, that's all for section 4.1, and then let's look at section 4.2, the addition rules for probability. Then talk about this, we need to talk about mutually exclusive events. So two events are mutually exclusive if they cannot occur at the same time. So when we talk about the frequency distribution and then we look at the classes, we want it to be mutually exclusive. And at that time, we introduced this already. So today, we just bring out this concept again, mutually exclusive. So now we know how to use, draw a Venn diagram. Then if we look at this, so this is event A. This is event A and this is event B. So they have no overlap. If you look at the Venn diagram, so they're disjoint, or we say they're mutually exclusive. Then we have a probability rule. When event A and B are mutually exclusive, then probability of A and B, so both A and B happen the same time, will be 0. So this is important because you have nothing overlap, and then you want to look at the probability of the overlap, which is impossible. So probability of impossible. So for basic probability rules, probability of impossible equals 0. And now let's look at the again the real addition rule. So this is the addition rule: probability or A or B. So if we look at A and B, they do have overlap. Then A or B stands for the shaded area. So the shaded area is A or B. So either A or B is fine. So the whole area is A or B. And then we want to look at the probability of this A or B. So it's going to be probability of A plus probability of B and minus probability of A and B. Why we want a minus? Because when you simply just add probability A and probability of B, so you add two circles together. So for this overlap area, you have two pieces of those. For this the overlap area, you have two pieces of those. So you have to minus 1 and to make it exactly an area like this. So everything just count once. So that is the addition rule. And let's look at an example. In a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. If a staff person is selected, find the probability that the subject is a nurse or a male. And we got a hint: generate a 2x2 table. So the easiest way to lay out this information is writing down a frequency table. But right now we only know from one dimension. When we have 2 variables all together, we just need a 2x2 table. Then we can say nurses and physician, and we have male and female. And we can just put down the information there. In a hospital, there are 8 nurses and 5 physicians. So regardless of the gender, so we have 8 nurses and 5 physicians. So the marginal total, we call it marginal total of nurses and physicians, will be 5 and 8. And 7 nurses and 3 physicians are female. So for the total of 8 nurses, 7 female, and then 3 physician female. Then that tells us we have 2 male physician and then we have 1 male nurse. If a staff person is selected, we want to find the probability that the subject is a nurse or a male. Probability of A or B. So let's write it here. Probability of then we can use this addition rule. So we need to write down probability of A, which is nurse, plus probability of B, which is male, and minus probability of nurse and male. So probability of nurse and male, for this one, it equals the F over N rule. So the empirical probability. So it's frequencies, right? Frequencies for that specific class divided by the total frequency in the distribution. So that gonna be we want the selected individual to be a nurse and also has to be male. Then we only have one count here, so the F is 1. And then the total number we have in the distribution. So we have 13, 8 nurses and 5 physicians, right? So a total of 13. So that is the probability of nurse and male. Use the F over N rule. And then probability of nurse, we have 8, right? So 8 over 13. Plus right of male, we have 3. So right here, 3 over 13. And don't forget minus 1 over 13. So the answer is going to be 10 over 13. And over 13. That's how we solve this problem, the addition rule. And that's all for section 4.2. And now let's look at, okay, let's just stop here. And then starting from section 4.3, we'll record another video lecture.